This will be for the con exercise, zeros of polynomials, multiplicity. So just some notes before we begin. Okay, and this will be more clear in a moment. But if you have a zero that results from an even exponent, the graph does not cross the x-axis. Okay, so you can see here this graph, it just touches the x-axis and then it goes back in the same direction. So it doesn't cross through the x-axis. Same with this one here. It just touches the x-axis and goes back in the same direction. It doesn't cross through the x-axis. So that is for an even exponent. And a zero that results from an odd exponent, it actually crosses the x-axis. So you can see here it crosses right through. In this section it's negative, in this section it's positive. Same with these two zeros, it goes from negative to positive and then positive to negative. So you'll see what I mean in a minute, but remember for the odd exponent it actually crosses right through the x-axis. So here it says a polynomial p is graphed, and here's our graph. What could be the equation of p? Okay, so they have p of x in factored form for all of the choices. So remember we said if it crosses through, it's an odd exponent. So this zero right here, the exponent is going to be odd. This zero right here, the exponent is going to be odd. And this zero right here, we can see it does not cross through. So this one here is going to be even. All right. So what would give you a zero of positive 4? Well, if you had x minus 4 equal to 0, x would have, if this were equal to 0, x would have to be 4, because 4 minus 4 equals 0. So in order to get positive 4 as a 0, you need to have x minus 4. And on that binomial, the exponent is going to be odd. Okay? And then on the next one, this is positive 1. What would give you positive 1 as a 0? Well, that would be x minus 1. Okay, and it crosses through, so that one's going to be odd. And finally, the last one, this is negative 1.5. Okay, and what would give you negative 1.5 as a 0? Well, that would be x plus 1.5. Okay, and this one right here, I'll just put an E. I don't have enough room. Let me fix this. Okay, so I abbreviated it with O's and E's. So the first one was odd, the second one was odd, and the last one was even. Now, just for your information, in their choices, they pretty much don't have decimals or fractions. Okay, so if you have x plus 1.5 equals 0, whoops, x plus 1.5 equals 0. If you multiply both sides by 2, and distributing the 2 times x is 2x, and 2 times 1.5 is positive 3. 0 times 2 is 0. So 2x plus 3 will result in the same 0 as x plus 1.5. So in their answer, they're not going to have a decimal. They're going to have 2x plus 3 instead of x plus 1.5. But anyhow, that one is going to be even. Okay, so this will be your answer right here. Odd, odd, even. Now, you don't have to write this out each time. You can just look at the graph and do some of this work in your head. Okay, x minus 4 is odd. So A, B, and C work. D does not work because right there it's even. All right, I expanded this a little. X minus 4 is odd. So A, B, and C all have an exponent of 1. If there's no exponent, it's 1. But answer D has an exponent of 2, so it's not D. X minus 1 is also odd. Okay, here it's odd because the exponent is 1. X minus 1, here it's even. X minus 1, here it's even. Okay, so it can't be B or C because we said it had to be odd. So it's answer A. If you want to double check on the last one, 2x plus 3 is even, and we do have that. So it's answer A. Okay, I believe these are all the same. A polynomial P is graphed. Here's the graph. What could be the equation of P? Okay, so everything's in factored form and the exponents are either even or odd. So let's check out our graph. Okay, so when it crosses right through the x-axis, that is going to be even. I'm sorry, that's going to be odd. When it crosses through the x-axis, that's odd. When it doesn't cross through, that's even. And same with this one right here. Doesn't cross through, that's even. All right. So let's see. This 0 is negative 2.5. All right. So for this, it would be x plus 2.5. All right, because if you set this equal to 0, x would be negative 2.5. So that's this one right here. That's odd. Then we have a negative 1. And how would you get a 0 of negative 1? You would have to do x plus 1. Okay, because if you set this equal to 0, x would be negative 1. And that one is even. And finally, the last one, this is positive 3. How do you get a 0 of positive 3? You would have to have x minus 3. Okay, and that one is even. Now, again, we said there's not going to be any decimals or fractions in the answer. So if you have x plus 2.5 equal to 0, you can just multiply both sides by 2. 2 times x is 2x, and 2 times 2.5 is just 5. 0 times 2 is 0. So instead of x plus 2.5, you can use 2x plus 5 in its place. Okay, if you set this equal to 0, or you set this equal to 0, it's going to be the same 0. All right, so this is your answer right here. All right, so the 2x plus 5 should be odd. A is good, B is good, C is good, D is no good because the exponent on 2x plus 5 is even. So we're looking at A, B, or C. X plus 1 exponent is even. A is no good, B is okay, and C is okay. So now we're looking at B and C. X minus 3 exponent is even. B is no good, C is okay. So it's answer C. All right, x plus 1 is squared, that's even. 2x plus 5 is to the first, that's odd. X minus 3 is squared, that's even. Answer C. Just for your information, the reason this works, let's say you have x minus 3, and that's squared, okay? You can plug in any values for x, and since it's squared, it's always going to be greater than or equal to 0, okay? So if you had something like this, you can get any positive number or 0. So on the graph, it's always going to remain above the x-axis because it's any positive number or 0. And let's say you had the negative of x minus 3, and you squared that. This part's always positive or 0, but then you have a negative sign, so the whole thing is less than or equal to 0. And all of these numbers for x, no matter what you plug in, it's going to remain below the x-axis because it's always going to be negative or 0. Now, if you had x minus 3 to an odd exponent to the third power, Well, that can be positive or that can be negative. So when you have your graph of something like that, it's going to cross right through the x-axis, because this can be both positive or negative. And if I put a negative sign out front, same thing. It's still going to cross the x-axis because this has the capability of being positive or negative. So even exponents, the sign will never change. It's either 0 always positive or 0 always negative. But odd exponents, it could be both even, or it could be both positive or negative for the odd exponents.